Hello, ladies and gentlemen. Today we're going to start getting into the different rules that deal with derivatives and some of the shortcuts that we use, which you guys are just going to know as the way to do them. First of all, I just got to clarify a couple things. This, what you see right up here on the screen, is the official definition of a derivative. And it's the difference quotient that we have been working on. I've been beating you up on it because I want to make sure that you know it. However, sometimes the functions, as you could, maybe had an experience with, could be kind of complex, and some of the algebra may be tricky. We also haven't addressed things like what if you have sines or cosines and stuff like that. So we will be talking about that sort of stuff, but we're going to do it in terms of the rules, not by going through the process of using the difference quotient every single time. See, the difference quotient is the real way to do it. But what we're going to do going forward is apply these rules, these little tricks of the trade, to a variety of functions. Now, there are a lot of derivative rules. There's not just one. Well, the one that you guys might remember, we recall, is the power rule. We used this earlier on in the year. Just to remind you guys, if you have a polynomial, you would take the exponent, put it to the front, and subtract 1 from the exponent. Now, as you can imagine, not everything is going to be a polynomial, which is why, going back to what I said a minute ago, we're going to have a lot of rules. Let's first recap with a little example. So like I said, we did this earlier in the year. We're going to apply the power rule, not the definition of the derivative. We are not going to look at that difference quotient for these. We're just going to use the little trick here. So, all right, so here we go. So f prime of x then is equal. You're going to go 3 times 6, which is 18. And then that's going to be x to the 5th power. And then minus 8x to the 3rd. And that is it. That is our answer. And I just want to reiterate this in case you're a little bit lost on the actual thought process. If I use the difference quotient on this function, I would get this as an answer. So you could have always go back to your previous homeworks from the past week or two with all the different difference quotients that I was giving you and just run them through the power rule. Okay. Well, you don't know all of the rules, but if it's a basic polynomial, you could do that. Or sometimes we have things that maybe don't look like polynomials, but maybe we can rewrite them in a way that they're a little bit more friendly. So first of all, you have a function here, y equals 3 over x to the 4th. And keep in mind, this doesn't mean 3 over x to the 4th like this. Well, back in Algebra 2, or even Algebra 1 for that matter, you should have learned that this equals 3x to the negative 4th. Remember, if the variable's in the denominator, his exponent really is negative. Now, apply the power rule here, so you could get y prime equals negative 12x to the negative 5th. All right, so I went 3 times negative 4. That's where the negative 12 comes from. Negative 4 minus 1 is negative 5. And then, you could rewrite that as negative. Then you have 12 over x to the 5th. We really want to avoid writing negative exponents. It's kind of part of the algebra tricks that we're going to have to, well, let me rephrase that. That was bad English, but we're going to have to use all of our algebra tricks that we've learned over the past couple of years to make sure that we don't leave things like negative exponents and complex fractions. Those are the two no-nos. Alrighty. Let's look at the next example I have here. Now, the square root of x. Oh boy, let's see if we can write that in another way. Oh, well, wait a second. Hold on a second. All right. So, the 5 times the square root of x is the same thing as 5x to the 1/2 power. Remember how we can write them as powers because we're using the power rule. Okay, now let's take the derivative. So 5 times 1/2, also known as 5 halves, that works for me. It's better to leave things as fractions, by the way. Get used to it. Calc works a lot better with the fractions until we start plugging things into the calculator. Then we have x. Now, 1/2 minus 1, 1/2 minus 1 is negative 1/2. So x to the negative 1/2, which means that this is going to become 5/2. Now that would move down below, and it's also to the 1/2 power. So put back in a radical. That's the best way of writing it. All right, now, before I go any further into 2 other rules that I'm going to talk about here today, I do want to talk a little bit about notation. And I've given you actually 3 different types of notation and haven't addressed a single one. Let's go back to the first page real quick. Right here, I talked about the function being f of x, and the derivative then would be f prime of x. Pretty standard stuff right there. Now, we also learned that besides calling a function to be f of x equals, it could also be of y equals. So if I give you y equals, his derivative would be y prime. Now, it does say find dy over dx, so I did forget that part right there on my final answer. dy over dx is, those are d's, is the same thing as saying y prime for our purposes now. Now, in the future, it will be subtle differences between these statements, and when it becomes relevant, I will instruct you. Now, this last guy right here, I just put d over dx. That means the words are, listen to me, the words are the derivative with respect to x of this guy, of the 5 radical x. It's not a y equals. It's not an f of x equals. It's not an equation. You're taking the derivative of an expression. So it's a little bit different, but I just want to let you know for right now, it's just a technicality in terms of the differences, and we're not addressing what they mean right now. I just want you to get the skill of how to do it first. And then we'll talk about when it matters, which is which. Okay, now, so we all knew the power rule. Hopefully we knew the power rule from earlier in the year. Now, the product rule, brand spanking new. If you've got 2 functions, 2 larger functions that you're multiplying together, multiplying is product, we're going to use the product rule. Now, it goes something like this. Let's say you're taking the derivative of 2 things. One thing might be f, the other thing might be g. The rule is, and you need to memorize this, f prime g plus g prime f. All right, so you definitely want to jot that down, and I'll show you how it works. You might get a little confused, but hopefully I'll work it out. Now, because we know things about addition and multiplication, right? F prime times g and g prime times f, and then you're adding them together. We got a whole lot of commutativity going on there. So that means here, because addition and multiplication are commutative, it doesn't matter whether you do f prime g plus g prime f or g prime f plus f prime g. You can move them around. And in blue here, these words are true. In general, just think that it's one function times the derivative of the other plus the other way around. You want a simple thing going on there. Here's a little example. I've got 2 things that I'm multiplying. So I'm going to use color here to kind of highlight everything that's going on. And I'm going to call this first parenthesis f. And then let's go orange, because it goes better with blue than orange. I'll call the second piece here g. So because it's this piece times this piece. After all, that's what the parentheses mean in math, right? All right, so let's follow the rule that I have right there. So, back to that. So then y prime is going to equal f prime. So let's go for f prime. So f prime, actually I'm going to write it out real quick here. F prime, just for notation purposes this time. Plus g prime, and we swap back to blue. Boop, 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 f. All right, now, I'm in the right spot. I want to be blue. F prime is the derivative of this guy. So that would be 2x plus 1. Then you just put G. All right, let me switch back to orange. All right, because here's G. I just want to make sure everything's color-coded and matches up. So it's 3 plus 1 over x, right, plus. Now G prime. That's what this is saying. We're doing G prime next. The derivative of 3 is 0, so that's going to go away. Now the derivative of 1 over x, and remember, 1 over x means x to the negative 1. So his derivative would be negative 1 x to the negative 2, which is negative 1 over x squared. So let's put that in there. And then finally the f, oh, let me switch back to blue. There we go. Now, we are not going to worry about multiplying these things together in distribution. You're going to stop here. This is going to be your answer. As long as we don't have any negative exponents or complex fractions, we good. This will be allowable on the quiz. Unless it's multiple choice. Now, I have seen textbooks where they give you answers and they multiply everything through and then add everything through, and then the people on the AP, because I do teach AP, so my focus sometimes is that they don't really care if you do things unless it's multiple choice and you're going to find the right choice. All right, gonna move on here. So that's the product rule. Let's try one. If you would like to pause and try this guy, go right on ahead. I'm going to work him out. So I'm going to let you know, I'm going to call this guy F. And I'm going to call the other parenthesis J. So here's my product rule, which is F prime G plus G prime F. Alrighty, so here it goes. By the way, people do get confused because they call the whole thing F, but these are just the F and G down here below just represent rules to how you go through it. Really, F prime is the whole, F is the whole thing, but don't get confused. Just use the product rule. All right, so here we go. So the product rule is going to be F prime is going to be equal to, let's see, the derivative of that is going to be 3x squared minus, I better talk about this, x rad x. X rad x, well, that's like saying x times x to the 1/2 power, which then would be x to the 3/2 power. So when you go for his derivative, it would be 3/2 x to the 1/2 power. So we're good. Oh, but we're multiplying that whole thing by 2. All right. So for multiplying by 2, you got 2 there, 2 there, 2 there, and then you got 2 there. So then it's 3x to 1/2. All right. So let's put that in there. 3x to the 1/2 power, and I'll clean it up in a little bit. Now, when I take the derivative of 4, if you recall, that just goes away. So there's my F prime. All right, let's go orange. G. Oh, just rewrite it. Boring. Plus. All right, take the derivative of him. So that's 40x to the 3rd minus 9x squared. And then finally, regular old F, you're just copying it over. This is getting in my way, so you can get out of here. Let's get over there. Yeah. And just some sort of clarification. All right. So that's x cubed minus 2x squared root x minus 4. All right, let me see. Do I have anything I need to clean up? Nah, not really. I mean, you could do this right there. The x to the 1/2 power. And then, the rest. Nothing really cleaning up for the rest of the problem. Kind of uneventful. Okay. All right, let's move on. There's one more rule we're going to talk about today. It's the quotient rule. Now, the quotient rule is if you're dividing two functions. So if I have an f and a g, and if I'm dividing two algebraic pieces, it's equal to g times f prime minus f times g prime over the g squared. Gotta memorize it, the quotient rule. Now, it's not commutative. Subtraction is not commutative, so the order matters here. Order matters. Bang. Okay. I also heard this one. Somebody heard this sort of thing, and it kind of stuck with me, and it's stuck with other people, and it sounds really annoying. But it's like saying low D high minus high D low over low low. You're like, what? Well, G's the bottom. That's the low. The F is the high part. Is on top. So that D high would be the derivative of the high. So it's low D high minus high D low over low low. You don't like it? Yeah, I know. I've got students every single year. They laugh at it. They say stupid things. That's dumb. I'll never use it. And then you end up using it. So, yeah, whatever. Let's try an example. Bam. All right, now quotient rules tend to require a lot of space here. So I'm going to think of the top part here as the F and the bottom part down there as the G. And you know what actually I'm going to do too is I'm going to use the whole color idea again because I can. Okay, so the answer to this, we want G, so you're just going to write x to the fourth minus 10x. Right, you switch colors here. Now it's going to be f prime, so the derivative of that, which would be 12x squared plus 4x minus, now the regular f function. And then g prime, let's switch back to orange, and then the g prime is going to be 4x to the third minus 2. All over low, so that's that guy twice, squared. Yes, you can simplify this often. You could multiply things out. Sometimes things will divide out. I am not asking you to do that yet. I just want you to get to this part where you can clearly see the different pieces. So don't worry too much about the algebra parts of simplifying your answer. We don't have a negative exponent, and we don't have a complex fraction. So as we say, we good. All right, one more example just to try it out. All right, this one could get a little ugly because I see that square root down there. But, all righty, so what do we got here? This part down here is G, just for clarification purposes. Top part here is F. All right, so it's low D high, so let's go for this. So then, all right, so F prime, the answer is going to go low D high, so it's square root of x plus 1, that's the low. The D high is then going to be 30x to the fifth minus 7. Let's take the derivative of the top part. Minus, that's low D high minus high. D low. Now, I'm not big on reinventing the wheel. We took the square root of, just to remind you, square root of x is x to the 1/2. So his derivative would be 1/2 x to the negative 1/2, which would turn into 1 over 2 square root of x. The negative part moves him down below, and because he's 1/2, he's inside there. So when you do the d low, you just get 1 over 2 rad x. And the derivative of 1 just goes away. That's all over. Low, low. So we're just going to rewrite the G. Don't square it out. Please don't square it out. Now, bad guy time. Bad guy time. Oh no, we have a complex fraction here. Oh no. So you want the good or the bad? Well, the good is I know how to do it. The bad is I'm going to tell you how to do it. But the good is, again, it's actually not that bad. You just take that denominator, that LCD that's giving you the agita, and you're going to multiply every term by the 2 rad x. Well, first of all, you see if anything cancels between this fraction and the f prime that's right here. I'm sorry, the f that's right there. Called it f prime mistakenly. Nothing cancels. You can't multiply this through yet because of the minus sign. All right, in order to cancel things out. But when you try to cure the complex fraction, if you remember, we handled these earlier in the year, and this is exactly why we handled them earlier in the year. You're going to multiply through by that 2 rad x. So you're like, all right, so what's that mean to me? Let me scroll down just to give myself a little bit more room. So for clarification purposes, when you multiply the first part here, you get this. These are supposed to be parentheses. Pen's not exactly liking me. Now, when you multiply, so that first term in the top, when you multiply it to that, you're just going to put it in front. When you multiply it to this term, it cancels with that, so you're just left with the following. And when you multiply it down below, you get that. So that's how you fix that complex fraction. Yes, you're going to have ugly things like this. No, this is not an easy class. Whoever told you that has lied to you. You should go find them. Call them a bad word like silly head. Out.